Welcome everyone to the third video in the SQL lecture series. We're going to start by loading some data into our SQL database, and we're going to use pandas to help us out here. Now, SQLite and other flavors of SQL generally, all include tools for reading and writing data with CSV files. However, frequently it's convenient or useful to be able to work with SQL databases from within Python. There are a number of Python modules that can be used for making SQL database connections, and pandas can in fact use a SQL database connection for processing data from SQL databases or even pushing data to SQL databases. We're going to take advantage of this here to populate our SQLite database with some data that we've prepared in some CSV files. We're going to use the Python SQLite module to make a database connection to our SQLite database. Remember, SQLite stores the database as a file on disk. In the previous video, we created this database file, and it started out as 0 bytes because when we created the database, it contained no tables and no data. Now, as of the previous video, we populated this database with 3 tables and several rows of data in each table. So now there are 16 kilobytes of ones and zeros in this database file. So we'll connect from within Python to that database using this SQLite 3 module. And then we're going to read in some data into pandas. So we have, for instance, customers in this customers table, products, and orders. And we can see that the data in these various tables follows a similar schema to what we encountered or created in our database before. We have, for instance, in the orders table, an ID, a customer ID, a product ID, and a delivery address. Here, for the delivery address instead, we've just done a delivery country. But we're not going to split hairs here. So we're going to use Panda's toSQL method to create tables in our database. We use the database connection we created with the SQLite 3 module. So we created a database connection which we've called con. And we simply say we're going to push a customers table into the database using this connection. We're not going to include the index of the pandas data frame. And if this table already exists, we're simply going to replace it. We can see more about this toSQL method in the pandas documentation. So we can see, for instance, if we do include the index of our data frame, we can specify what the name for that index should be when it becomes a column in the SQL table. And once again, if we go to the I/O tools user guide in Pandas, there is more information about reading and writing SQL or issuing SQL queries via Pandas. For our purposes, this is all we're going to make use of today. So now, if I select everything from orders, I'm going to want to limit that. We can see there's a lot more rows now. Since we replaced the old table, if exists, replace, so we replaced the old orders table, delivery address has now been replaced by delivery country. Again, this is just a matter of brevity, since there's quite a lot of data in this file, and when I made it, it was much simpler to simply generate countries rather than cities in countries, because I would have needed a list of cities in various countries. Much easier to just get a list of countries. But now we have several tables with a more realistic amount of data in them. So we can actually work through some examples and do some calculations that will be a little bit more interesting than with the data that we had entered by hand previously. All right, so let's start actually manipulating some of this data now that we have some more realistic tables to work with. And let's begin with filtering and sorting. So in Pandas, we would filter by creating some conditional statement and slicing the data frame using that conditional statement or that Boolean series. In SQL, we'll also write a conditional statement, and we will use it with the where command, which will perform the filtering for us. So here, we're going to select all the order IDs and delivery countries from orders where the delivery country is India. And we're only going to return the first 10 results. So we can see here a variety of orders, all originating or all being delivered to India. And if I increase this limit, we'll see even more. Again, I wouldn't want to get rid of the limit, as I might get hundreds or thousands of rows here, which could crash my notebook. Notice here we have a single equals sign, which is different than we're accustomed to in Python, where equality comparisons are made using a double equals sign. In SQL, we don't generally make assignments like we do in Python. We're not assigning values to variables. So there's no ambiguity or no necessity for a single equals sign to indicate assignment rather than equality. And this is an idea that might take getting used to. After working in Python so long, it will be tempting to try to assign values to variables. But that's not a feature of SQL as a language. SQL is a query language. It's meant for performing transformations and aggregations of data present in databases. It is not meant for writing programs or applications. And therefore, we don't typically assign output to variables. We might alias a table as something else, which we'll see later, as that can be useful when building up a multi-stage query for more complex aggregations. Equality is not the only comparison we can do. We can also filter based on inequalities. So here we'll select all the products where the price is greater than 20, but again, we're only going to print out the first 10. So we see a variety of products here, all with prices greater than 20. And we're seeing the first 10 of them. Or we could do less than or equal to 20 if we wanted. And now we're getting all the products, the first 10 products, rather, where the price is less than 20. We can also do pattern matching using the like keyword alongside where. So if we wanted, for instance, to find orders where the delivery country was a country beginning with S, we could ask for those columns from the orders table where the delivery country is like S %. So here %, could be any number or combination of letters following S. So we see orders going to Spain, Senegal, Sweden, Slovakia, South Korea, all different countries beginning with S. This is similar in pandas to the string contains method. A major difference between SQL's like syntax and the pandas string contains syntax is pandas uses regular expressions for pattern matching. We haven't talked about it in detail, but regular expressions is a whole set of characters for indicating spaces, digits, and other characters, and specifying the structure of various patterns in strings that we can search for. And in particular, there is a Python flavor of regular expressions, which is just that particular set of symbols for pattern matching. SQL, in its various flavors, also has a regex-like set of symbols for performing pattern matching. And each SQL flavor, unfortunately, has its own variant with some different symbols. There's some overlap between them, but in general, you may have to look up how to write pattern matching strings for your particular flavor of SQL. So here, in this SQLite tutorial, it shows we can construct patterns using %sign and underscore wildcards. So %sign is a wildcard that matches any sequence of 0 or more characters, while underscore is a wildcard character matching any single character. So, for instance, looking back at our result, there's multiple what could we do here? Yeah, unfortunately, I can't come up with a good example highlighting the underscore. But if we wanted, for instance, countries beginning with S that contain exactly 5 characters, we could do S and then 4 underscores. There's only one country that fits that criteria, which is Spain. Just trying to find maybe some. Here we go. So Armenia, Algeria, Austria, Albania apparently all have the same number of letters and all begin with A. So here we have something like 6 letters, A, and then 6 letters. So all these countries have the same number of letters and begin with A. And again, different SQL flavors may have different pattern matching conventions. If we were looking at PostgreSQL, they have pattern matching using like, which has this underscore and %sign syntax again. But they also have regular expressions accessible from similar to. So again, pattern matching is something you may want to look up documentation for your particular flavor of SQL. Something all flavors of SQL have in common is the in keyword for testing membership. So this is similar to Pandas isIn, where we can check a series or a data frame, probably a series, to see whether the values in a series are contained in some set of values. And now this could be an actual set or a list or a tuple or any kind of list-like container of values. So it will check, for instance, if we have a series of different animals, we can check row by row whether the values in that series are in the list cow and llama. Likewise for SQL, we just use the in keyword. So select everything from orders, all columns from orders, where the customer ID is either 10, 200, or 400. And there we see all the orders associated with those customer IDs. And just as we can in Python, we can also combine these logical filters with logical operators. So we can not only select the orders where the customer ID is in this group of 3 customers, but where the delivery country is not Madagascar or Canada. And we see we filtered out those rows with the delivery country being Madagascar or Canada. So only Mexico and Sweden remain. Or we could use an OR logical operator to get products where the price is less than 10 or greater than 30, but nothing in between. Finally, we'll talk about sorting. Sorting is done using the order by command. If we want to simply sort our orders by customer ID, we can select all columns from our orders table and order the results by customer ID. So we'll see the lowest customer ID first, followed by the next lowest. Order or sorting is done in ascending order by default, similar to the Python convention. We can order by multiple columns and specify whether we want to order in ascending or descending order. So here, we'll order by customer ID again in ascending order, as is the default. But we're going to also secondarily order our results by product ID in descending order. So here we see when we only sort by customer ID, 307 comes up followed by 508. Then it jumps down to 431. When we order secondarily by product ID in descending order, 592, the highest product ID for customer 1, ends up first. And we see all the orders belonging to customer 1 with the product IDs in descending order. So that's an introduction to some of the basic commands for filtering and sorting data in SQL. In the next lecture, we'll talk about performing data aggregations, followed by joining tables together to answer questions that depend on the relationships between tables.